So here we have an ellipse because we have x squared plus y squared, and the coefficients on the x and y squareds are different, meaning that there's different expansions and compressions along the x's and y's. So we're going to put this into our form that we want. So we're going to first of all divide by 36. So we end up with 4x squared over 36 plus 9y squared over 36, and that's going to be equal to 1. So we've divided both sides by 36. I'm going to simplify that fraction, the common factors of 4. So we get x squared over 9, and we end up with y squared over 4. So factoring out those common factors, we end up with these simplified fractions. From those simplified fractions, we can see that a squared is equal to 9. So a is equal to 3. B squared is equal to 4. So b is equal to 2. The center is at 0, 0. I'm going to use the x-axis radius to go 3 to the left, 3 to the right from the center. From the center, we're going to go 2 up and 2 down. And then we can sketch in our ellipse that goes through those points. Okay, so that represents our ellipse. The major axis along the x has a length of 3, and the minor axis along the y, which has a length of 2. That represents the distance from the center. So rectangular hyperbolas and non-rectangular hyperbolas are the same thing, except that we have a little bit different algebra, and that we do have to worry about this minus and plus minus here. So when we have the non-rectangular hyperbola, it looks like in this form here. So expanded out, this would look like this: x squared over 81 minus y squared over 16 equals 1. Now it's x squared minus y squared equals positive, so it is trans x. Okay, and these values, the a squared and b squared, well, a squared is 81, which makes the a value equal to 9. B squared is equal to 16, which makes the b value equal to 4. Okay, so once we have this, the way we can draw this is we start at the center, 0, 0, and along the x, I'm going to go 9 to the right, 9 to the left. The b values, I'm going to go 4 up and 4 down. Okay, so this is exactly like the ellipse. So with the ellipse, we would have sketched in an ellipse through those points. Okay, this is different. With the non-rectangular hyperbola, those points allow me to work out those diagonal asymptotes. So I'm going to mark the corners here of this box. Okay, so I want you to imagine a box here. And that box allows me to draw a diagonal lines through the vertices, and that those diagonal lines represent the slopes of the asymptotes, or the equations of the asymptotes. And that ratio of b is 4, a is 9 gives us a slope. Okay, so I'm going to draw it in along this way. Okay, we have the trans along the x-axis. So the x vertex here represents the vertex we're going to use to draw. So we just start with that vertex, and then we draw this as a trans x graph. Okay, so we start at the vertex and then just follow the asymptotes. So then that represents a non-rectangular hyperbola. The positive one means it's trans-x, and the a squared and b squared allow us to get the a and b values, which gives us the slopes. So what's important to recognize is the reason why I drew in that box and drew the diagonal in is because through that diagonal then, we have the slope value. And the ratio of that slope is going to be b is 4 and a is 9. Okay, so the slope of the asymptote in this case is going to be plus minus the b over the a, or in this case 4 over 9.